Hi there. In this video, we're going to summarize what we found with our simulations in the last video and talk about standard error and the central limit theorem for proportions, and then we'll also see what else we might want to look at for proportions. Okay, so you'll see this looks really familiar, but I think it's good to go over it again. It never hurts. A standard error, or SE, is the standard deviation of a sample statistic. So it's the sample-to-sample variation. That's why we use a slightly different term, but it is calculated using the standard deviation formula, but it's just of samples versus of individuals. So we use SD for individual to individual, and SE, oh sorry, I said SD, but I wrote SE. And then SE for sample to sample, okay? So standard error just helps remind us that, okay, sample to sample variation is less than individual to individual. And this also changes based on the size of your sample size, right? Okay, so then central limit theorem, which we saw with means, says regardless of the population proportion, for large enough random samples, and we'll talk about what's large enough from a large population, the distribution of a proportion follows a normal distribution. So we saw that, symmetric unimodal shape, right, that we're used to seeing with the simulations. And it's centered at the population proportion. Then the larger the sample size, the smaller the standard error. Okay, that's what we found. If I look at, oops, where's my previous page, we saw that they were still all right about 0.37. They're going to vary a little bit, but they're very close or right on 0.37, and then the standard error went down as our sample size went up. And we approached, soon as we got to 10, it was pretty much a normal distribution shape. Okay, so the next thing I want to say is for the value of P and N. Okay, so this has to do with large enough random samples. How do we know when we're going to get to that normal shape? Okay, so I want to ask a question here. Does the value of the proportion affect the shape of the sampling distribution? Okay, so we can actually use, I hope you still have your app open from the previous video, but if not, you can get there again pretty easily. It's good practice. There's actually a slider bar. If you check the show sliders box, there's a slider bar where you can move the value of P around. That's the success probability. And so let's do that and see what happens with the shape. Okay, so I had used the show previous results before, but what I want to do is show sliders. Okay, so this brings up a slider for our population proportion, P, and our sample size. So I'm going to keep the 100 for now. But what we can do is see, well, what if it wasn't 0.37? What if it was more in the middle, like 0.5? Okay, so in the middle, that looks even more symmetric, doesn't it? What if we, this would be something else, not type O blood, but something else that had a really high proportion. Okay, so when I get very far to the right, when the P is to the right, then it's skewed to the left, right? Because we've got more values on the upper side. And then let me slowly move it back down below 0.37. And it takes a little time to adjust the graph because it's calculating all 2,000 simulations again. Okay, so now I'm getting under, now I'm down to 0.2. And you can also see the values are shifting at the bottom, but I'm mostly looking for the shape right now. Okay, so when I get really low, then it is now skewed to the right. Okay, so we do have to be careful if we have a really low or really high proportion, then we got to watch out for our shape, okay? Now let's see what happens. Let's keep it at this skewed shape, but would the sample size help that? Like if I do a larger sample size, it was 100, now I'm going almost to 200, it is getting more symmetric, isn't it? Okay, I love these sliders because we can see. Okay, so even if I get up to about 500, 550, that looks pretty symmetric, right? And then it just should get better after that. Of course, there's variation, so it bounces around a little bit. Okay, so what it turns out, we need a bigger n if our p is very small or very large, you know, close to 0 or close to 1. If it's in the middle, then it's going to be fairly symmetric early on with a smaller sample size. But so our success, or not success, our sample size condition is actually going to depend on n and p for this one. Okay, so let me go back to the notes so I can write out what we just found. Okay, what do you notice? So we moved the success probability, so that's our P, from left to right. What do you notice about the shape? Okay, so when P is close to 0 or 1, the shape was skewed. When P is more in the middle, very technical terms, the shape was symmetric. Okay, and then the second part is what we did next. Increase the sample size slider, so that's n, to 1,000. Did I go all the way to the right? Let me double check. Oh, almost 928. 1,000 is the biggest one it will show. So even if your success probability is very small, oh wow, if it's 0.001, then it's not gonna, 1,000's not even enough. But even if you get just a little bit beyond that, 0.035, it makes it symmetric. Okay, so what changed? So when starting from a skewed distribution, increasing the sample size made it more symmetric. Okay, so for right now when we're doing simulation, you know, we don't have to worry so much about all the conditions, but when we get to the theory towards the end, then we'll get a little more detailed into what are the exact conditions that n and p have to have, okay? Okay, but right now, we're going to be finding proportions and probabilities, and so we're counting from an actual simulation. So let's go ahead and do that. So keeping the same simulation I've already got going, because it says simulate a sampling distribution with p equal 0.37 for the proportion of people in the US with type O blood. Simulate 200 random samples of 100 people. Okay. It says, in what proportion of random samples do you get a proportion of 0.42 or greater who have a blood type of O plus or O positive? Okay, so we want greater than 0.42. So we were doing this with means, so let's see how we do it with proportions. You can uncheck the sliders if you want. It's up to you. But actually my sample size, I was playing around with it, so it actually changed what I was doing. So be sure to put that back because that will change your answers. So 0.37, oh, I changed that as well. So hold on. 0.37, let's start over. 0.37, 100, and then 2,000 simulations. So I'm going to hit draw samples. Voila, it does it just like that. Okay. Okay, and now our counting is on the left. So we want as extreme as, we want greater than or equal to, this one has symbols, greater than or equal to 0.42. I'm going to hit count. And similar to the other one, because the other app was Rossmann Chance also, it shows highlights in red and gives you a red line at that dividing point. So that 0.42 to the right of that is red. And then it's counting 325 times out of 2,000. And that's equal to 0.1625 or 16.25%. So not very unusual to get 0.42 to have 42% or higher in one sample of 100 people that have type O positive blood. Okay, so let me show you back on the notes where I wrote that out. I wrote 325 out of 2,000, and then that gives me 0.1625. And again, just like in the last video, I wrote it out in symbols as well. So the probability, but this time we're using p hat, greater than or equal to 0.42, that's equal to 0.1625. Okay, I bet you can guess we're going to go the other way. What proportion of samples do you get a proportion with less than 0.25? Less than 0.25. So let me go back. Now I'm going to click this greater than or equal. So remember, this points to the right. So if that's greater than. If I click on it once, I get to less than or equal to, and it points to the left. And you can also see the red areas highlighted. So make sure that, visually matches up with what you're looking for. Less than 0.25 is to the left, and many fewer that time. So that is 11 out of 2,000. Whoops, not 111. 11 out of 2,000, which is 0.0055. So that one's much less likely to happen due to chance. 0.0055, and then to write my probability, if it was given in symbols, probability that p hat is less than or equal to 0.25. Less than a quarter of people getting in the sample with type O positive blood would be 0.0055. Okay, I hope that helps. I'll see you in the next video.